Okay, I'm recording this. We are sitting right here. We're going to review today. Review is right there. If you need it, it is over at the Google slide where it says review on Wednesday. Click on that and up will pop this review that we're going to do. This will match. What I mean by match, I mean that if you go to my math lab, you will see that number 1 is a square root property problem on your My Math Lab practice test. Number 2 is a quadratic formula problem on your practice test at My Math Lab. Number 3 is solved by the method of your choice on the review sheet at My Math Lab. Different problems, so just like we do in class, we'll be going over these and you'll go do the review. And some of you have already started it, which is just fine. The review counts as a regular section. Its grade counts towards your grades and a bonus point for getting 100% on that. This will be 25 problems, just like the My Math Lab one is 25 problems, just like your test is 25 problems. These are not multiple choice. The ones on the review are not multiple choice, but the ones on your test that you will take before Friday at midnight, those are multiple choice problems. So your test is multiple choice. Oh, at My Math Lab, if you'll look in the upper left-hand corner of each problem, open up a problem, in the upper left-hand corner sits a number like 1.5.21. That tells you what section it comes from, 1.5. If it's 2.1.23, that tells you it's coming from section 2.1. So that might be helpful to you as you go back and try to figure out your errors. On the test itself, those 25 problems that will look an awful lot like these 25 problems, just different numbers, those 25 problems will be randomized for you so that your first problem may be number 7, where somebody else's first problem will be number 24. So yours will not be in the same order as anybody else's, statistically speaking, in the class. So different order for yours, which also means that your first problem will not be square root, your second problem not be quadratic. You're not going to be able to memorize them like that. So your problems will be not in this order on your test and not in the same order as anybody else taking this test. I think that is it. On the, let's see, how many scratch paper? You're allowed to have as much as you think you need, Chloe. The limitation to that is that you've got to show me each one of those. Just a sec, Felicia, and I'll answer that. You've got to show me each one of those scratch papers before you take your test. So, don't have them in a notebook. My gosh, they can't be in a notebook. That would be, and I'm not saying you asked about a notebook, but they cannot be in a notebook. That would be full of notes, potentially. But you've got to be able to flip all the pieces of paper over for me. If in the middle you realize that you need more scratch paper, then tell me what you're doing. That'll get flagged that you were talking. And show me those next couple of papers that you pull out quickly as you can, and show both sides of those, that kind of thing. Some of you, when you send me scratch paper back or showing me clean sheets, at the end when you send me a photo of your scratch paper, I don't need the clean sheets taken pictures of. I just need the scratch paper in your handwriting so that I can make sure that you did certain problems the right way, that kind of thing. I don't need blank sheets sent back to me at the end of the test. Felicia asked if it's timed. Yes, it is timed. It is 90 minutes, and that's these 25 problems. I'm thinking of bumping it up to 120 minutes just for fun. It's not meant to be a super duper time test, and I don't want to stress anybody out. So I think I probably will go back in and bump it up to 120 minutes. So 2 hours. It shows you the time on there. So you'll know what time you have left. And I'll see how the timing goes as people take the test and maybe back up on that a little bit in the other tests. Okay, let's get going on this. I think I'm ready. Are you ready to go? Anybody have any questions other than those two? If you think of something, ask, please. The test is due Friday night at midnight. It opens today at noon, and it'll be open all day today from noon until midnight, and then Thursday from midnight to midnight, and then Friday from midnight to midnight. Do not try to take this test late. You can't. It won't let you in, and I won't let you in. You have to take this test by Friday night. Take care of business. This is the first of 5 tests. This is just the beginning of February. If you can't handle the deadlines now, you're not going to be able to handle the deadlines later. So do what you need to do to take this test by Friday midnight. Okay, first problem, let's see. We are solving by square root. And the problem is x minus 6 squared equals 64. You know, in order to get this x equals, you're going to have to get rid of that parentheses with a square. In order to do that, you take the square root of that side, because squaring and unsquaring cancel each other out. Whatever you do to one side, you have to do to both sides. So we end up with x minus 6 equals, square root of 64 is 8, but you put the radical on, so you have to consider both the plus and the minus 8. We're trying to get x equals, so move the 6 over to the other side. So we get x equals 6 plus or minus 8. Both of those are rational numbers, and they're combinable. So you're going to need to combine them. There won't be a 6 plus or minus 8 as your answer. So you need to separate them out, 6 plus 8 and 6 minus 8. So you get a negative 2 and you get a 14 out of that. And those are your answers. Okay, number 2, let's do quadratic formula. That's what you're told to do. X squared plus 9x plus 11 equals 0. There really won't be another way of doing this problem. You'll have to use quadratic formula, and you'll have to have it memorized. I'm not giving it to you on the test. Very little will you have to have memorized in terms of formulas in this class, all throughout, but that is one of the things you need. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to use so many parts of this. Negative b over 2a will be something we're using, and then when you're looking for the discriminant, you use this. We're using this right now, the entire formula. There's just so much we use of this. It's a crucial part of this class. Okay, if you are a table setter-upper, A is a 1, B is a 9, and C is 11. You don't have to write that on there. While I'm thinking about it, when you go to take your test, the instructions for your test are slightly different, and each time I'll change them slightly different, get them a little better, get them more geared, focused for that particular test. But the first thing it tells you is that you cannot have your phone in your room with you. Duh. So make sure that your phone is not in your room with you while you take the test. As soon as you've submitted, you can run right out and get your phone. That's fine. The other instructions are all the same except for the bit about the scratch paper. What I wanted on the practice was I wanted you to write every problem down, show every step, and box your answer so I could get a handwriting sample from you. This time, what it says on your instructions, you do not have to write every problem down. What I remind you of on your scratch paper is that you need to write what you need to write to solve the problem. And I write, if I can't do it in my head, neither can you. Write what you need, or something like that. You know, I mean, it's just, if you're not trying to work around this test and trying to cheat on this test, there's going to be no problem. There's going to be no problem with the amount of scratch work you do, because I know that you got to write a couple of steps in order to solve a problem. Like, you're not going to be able to do this one in your head. Show me the steps. Doesn't have to be every stinking step like I show you. I know you can go from here. Many of you can say 14 and negative 2. You don't need these. I get that. I totally understand that we're at different levels of ability. And what I write is every stinking step for students who need every stinking step on that particular problem. You may not, but you need something more than going from here to the answer. So show me what you need to show me. Okay, down to this one. I would expect to see a few steps on this one. Get a negative sign, then b, that's a 9. B squared minus 4 times a is a 1, c is 11. And I'm going to pause here and make sure that I don't have a sign change happening in the middle of this radical. It's a negative times a positive times a positive, so that will stay a negative. I'm good. That's the biggest mistake I see students make is subtract when they should add or add when they should subtract. Check the signs. All over 2a. Okay. Negative 9, 81. Negative 4 times 1 times 11 is negative 44. And then we've got 81 minus 44 is 37. So we get negative 1 plus or minus the square root of 37 over 2. There's our answers. They may separate them out. I just don't remember in test gen into negative 9 plus square root of 37 over 2, comma, negative 9 minus square root of 37 over 2. You should be prepared to see either one of those and recognize it as being right. We cannot go further like we did here where we added 6 and 8. We can't go further because 9 is a rational number and the square root of 37 is an irrational number. They're not like terms, they're not combinable. So we're good. Okay, number 3, solve any old way you want. Let's see what we got going on here. I'm going to FOIL this out first. Outside is 7x. Inside is 4x. There, I'm going to combine these two. And then certainly if we're doing zero factor property or we're doing quadratic formula, we need a 0 over here. So let me send this guy over here. Okay, I'm going to try this using zero factor property, 7x and x. I know the signs need to match and they need to be positives. I could put the 1 here. That'll only give me 7x. I'm going for 11. Put the 3 there. 7 and 3, that's 10. That's not going to give me 11. And if I reverse the numbers and put the 3 there, bam, I got 21. That's way too much. So this will not factor the traditional way. I'm going to go use quadratic formula. Okay, so A is a 7, B is 11, and C is 3, based on this one right here. So let's see, we got a negative 11, 11 squared, 7 and 3. Before I go downstairs, I'm going to look at this. Negative times a positive times a positive, it'll remain a negative. So we got 121. Negative 4 times 7, well, negative 4 times 3 is negative 12, and 12 times 7 is 84. 121 minus 84 is 37. And that's good. Again, they may write it separately for you as a plus version and a minus version. Be able to recognize it from there. Okay, let's look at number 4 and 5. They're similar problems in that they're those substitution problems. They're those ones where you have to let mu equal what sits behind the coefficient of b, what sits behind b. Let's see. Okay. Let me straighten myself out here a little bit for you. There's a little better. Okay, we've got a look-alike. We've got something that looks like it wants to be quadratic. So I am going to let mu equal that piece right there, whatever sits behind the b. That way I'm going to form this into a regular quadratic. 0 equals, still we don't have any x squareds. Oh, there's an x squared. I'm substituting in place of him a mu. 257, got a minus sign. And then this will always be mu squared, but let's see why. X squared is mu. This is a squared version of that. If we square that, if we square x squared, we get x to the fourth. So we can square that in substitute. And now we've got a regular old quadratic formula or quadratic problem, x squared or mu squared, a variable squared, variable to the first power, and no power here, variable to the 0 power. So let's set this up. These will be factorable for you, mu and mu. The signs will need to match. I either need to put 2 plus signs here or 2 minus signs. Because this problem needs some negative, I've got to put in negatives. I'm looking for 2 numbers that multiply to give me 256 and add together to give me 257. So that's going to be 256 and 1. 256 times 1 gives you that. And outside, well, 256 and 1 add together to give you 257. So let's separate these out. And now, don't forget, this problem is not being solved by mu's. The original problem was x's. So we've got to resubstitute. We've got to take this and go back in. So in place of mu, we're now going to put x squared. And now we have to solve for x. If it's squared, I've got to get the square root of it. That will give me x equals, which is exactly what I'm looking for. If I take the square root of one side, I have to take the square root of both sides. I put the radical on, so I need a plus or minus version. If you don't know what the square root of 256 is and you haven't looked at the answer sheet, and let me show you how to, and you won't have an answer sheet on your test, so let's be sure you understand how to operate the machinery. We're doing square root, and that's right here. It's above the x squared. So do second x squared, and that will give you the radical symbol. And then put 256 in there, and we get 16. So 16 times 16 is 256. And then square root of 1. I put the radical on, so I need a plus or minus on it. And then the square root of 1 is 1. Be prepared to see something like negative 16, negative 1, 1, and 16, something like that. Both positive and negative versions, positive and negative versions. That's what the plus and minus indicate. Okay, let's do another one of those problems. Number 5, 6x to the 2/3 minus 29x to the 1/3 minus 5 equals 0. Okay, we got this little guy right there. So we're going to substitute because this guy wants to be quadratic, but he's not. He's not x squared and x to the first. So let's substitute in mu in place of x to the third. Start back here. Oh, there's an x to the third. Put a mu. Oh, there's an x to the 2/3. That's the square of x to the third. So if we're substituting mu for this guy, if we square this guy, we got to square that guy. So mu squared, and then we've got a 6. All right, that's quadratic. Let's factor it into 2 sets of parentheses. I'm going to try 2 mu and 3 mu. That's normally what would work in these problems is getting the 2 numbers that are closer together rather than 6 times 1. But when I try to do this, I need 2 numbers that multiply together to give me 5. Well, let's do signs first. The signs, I've got a minus back here, so the signs need to be different. And then what makes 5? Well, 5 times 1 makes 5. I got to get to 29, though. See how 6 times 5 is really close to 29? So that tells me that I'm not going to be able to collect 29 out of the middle term. For instance, if I put 5 there, I'm only going to get 15 and 2. That's 17. That's like half of that almost, a little bit more. So when the middle number is a huge number, like the multiple of those 2, that's what we want to go after then. So 6 mu and 1 mu will give us 6 mu squared. Again, the signs need to be opposite. And if I'm trying to get almost a 30 here, I want to pair 6 and 5 together. So I'm going to put 5 there, so at the outside, there's a negative 30 mu. The inside will be a plus 1 mu, and I'm getting that negative 29 mu that I was looking for. So good deal. Got this factored properly. Let me set up each one separately. So mu equals 5. And over here, I'll move the 1 over and then divide by 6. Okay, so now we've got mu. We're not done. This problem is not about mu's. This problem is about x's. Began with x's. So let's go in place of mu, revert back to what we substituted. Is changing the mu to an x to the 1/3. Then your brain has to think, I need to make this an x. It's an x to the 1/3 right now. What am I got to do in order to make that exponent be a 1? What you have to do is multiply times his reciprocal. 1/3 of 3 is 1. So on both sides, I've got to raise them to the 3rd power. 1/3 times 3 will give me a 1. But if I do that on one side, I've got to do it on both sides. So I'm going to raise it just to the 3rd power. Over 1 goes away, you know that. So 5 to the 3rd power, if you're using your calculator, 5 humpy 3 will give you 5 to the 3rd power, 125. Or you can say 5 times 5 times 5. That works just as well. Over here, a negative raised to the 3rd power is a negative. 1 times 1 times 1 is 1. And 6 times 6 times 6 is 216. Much more simply, if you're in the mood, put it in parentheses. Negative 1 ABC6, close the parenthesis. So there we've got negative 1/6. That's negative down here. 1 ABC6 because it's a fraction. And then humpy, raise it to the 3rd power, and you get negative 1 over 216. So use your calculator. You paid for it. Okay, let's look at number 6. It says solve the radical equation. So that tells me I've got an equation. Sure enough, I've got an equation. Tells me I've got a radical in it. There's the radical. And if I want to solve it, I need to get x equals like we've been doing on all these problems. Okay, so I got to get rid of that radical. I'm going to have to square this because as we've already learned, squaring and unsquaring cancel each other out. I'm left with 4x plus 44 over here. If I square one side, I have to square both sides. This sets up a FOIL problem. First, outside, inside, last. That'll give you x squared plus 16x plus 64 when you FOIL it out, x plus 8 times x plus 8. Okay, now I see an x squared, so I know I'm going to have to do a quadratic on this. We'll try to factor it using zero factor property the normal way. I'm going to have to move 4x over, minus 4x, column it up, minus 44. Okay, so we get 0 equals x squared plus 12x plus 20. If you don't like the 0 over here, just move him over to the other side. That's not a biggie. We factor this, x and x. The signs need to be the same, and they'll need to be positives. I'm looking for two numbers that multiply to give me 20 and add together to give me 12. So I'm thinking 1 times 20, 2 times 10. There we go. 2 times 10 multiplies to give me 20 and adds together to give me 12. Now, so we've gotten the 0. We did the factoring. Now let's use the property that allows us to separate them out and get x by himself by moving 10 across the equal sign. Moving 2 also across the equal sign. Now the deal with this is that when you have squared these problems, weird things can happen underneath here. So we've got to test them both. So let's check this one first. I'm going to put a -2 in here. 4 times -2 plus 44 equals -2 plus 8. I'm going to work that out and see if it makes a correct statement. 4 times -2, that's -8. -8 plus 44, that's the square root of 36. -2 plus 8 gives me 6. And sure enough, square root of 36 is 6. So -2 is a good answer for me. That checked out. Let's check -10 and see if he works. Put him in here. The square root of 4 times -10 equals -10 plus 8. Right now, I know that's not going to work because -10 plus 8 gives me a -2. Radicals in this country, if we take the square root, and we didn't put the radical on, and we didn't, it's the first thing you wrote when you wrote this problem, we're always going to be taking the positive square root. So the left-hand side of this equation will be a positive number. It can't be a negative number. But let's just work it out. 4 times 10 is 40, -40, plus 44, that gives me a +4. The square root of 4, you know, is a 2. 2 does not equal -2. So that answer, although it wanted to work, it looked like it worked, it doesn't. It looked like it worked, it doesn't work. So the only answer is -2. -2 is it. -10 does not work. And you have to be aware of that as you square problems. When you square a radical, you have got to do a check when you square a radical. Okay. Let's move forward. Number 7. I believe that's the only problem that you have to check here when you square radicals. It's the only pitfall, the only landmine we've got in this section. Okay, number 7 is asking you to solve the equation 2x raised to the, that's 11 over 2. 11 over 2. So 2 times x raised to the 11 over 2 minus 6 equals 0. Okay, we're going to solve this equation. Solve, so we know we've got an equal sign. We know we've got an x. We need to get the x by itself. So we're going to have to move the 2 and the 11 halves and the 6. The order of that, you just get closer and closer and closer, more intimate with the x, if you will. So the furthest thing out is this 6. Let's pitch him. So we've got 2x to the 11 halves equals 6. The next thing closer to the x is the 2. He's attached by multiplication. We're going to get rid of him by division. So divide by 2. Now we're ready to get rid of the radical. Just like in the previous problem, in order to get, or 2 problems ago, in order to get rid of an exponent that's a fraction, you will multiply times the reciprocal. So 11 halves times 2 11ths, that gives you a 1, and we get x equals. Whatever you've done to one side, you have to do to both sides, and we end up with that answer, 3 raised to the 2 11ths. That should be good enough. Let me check my answer if I converted it. Number 7. Yeah, I did. I think my math lab will convert this, and so what you know is that anytime you've got a rational exponent, let's do this number to it, put the 3 in there. The denominator is the index, and then we're raising that number. We're either doing that, or you can put that 3 inside and put the exponent right there and make that a 9. I don't remember exactly what's happening with number 7 on your test, but if there's that level of confusion on it, if you get it wrong, I'll probably go back. You know, I'm going to look at these later and make sure that everything is cool. But my memory is, although this is a fresh test, this was not the test I used last semester. So if I've pulled a bad question, I'll repair that for you. So don't stress too much. If we've got a bad question and a bad question is like something that over half the class misses, that means somebody screwed up, and it's probably the one who taught it that screwed up. Or it's just a bad question, like it's asking you to think of too many different things that we haven't practiced. I'll give you credit for it. It may just take a day or so, but I'll figure it out, or I'll hear from you. So no worries, this is a good answer, or this is a good answer, or I don't even know if it gets this messy on your problem, because I did do them, so it didn't occur to me then. Number 8, we're asked, is it a function, and name the domain and range. So we got that point, and that point, and that point, and that point. And you won't have to worry about braces because it's a multiple choice test. So you don't have to worry about, are you presenting the answer perfectly? The answers will be presented to you. So let's see, domain is the x's. So -3, -2, 0, and 5. The range, that's what's happening on the y's. That's 6, 5, 0, and 5. Well, we already put a 5 right here, so we just got those 3. You wouldn't expect to see it twice. And is it a function? Remember, if it's a function, if the x does not repeat. So just look at the x's. -3, -2, 0, 5. Listen to yourself. If you never said the same number twice, you're good. So this is a function because x does not repeat. Because x does not repeat. You don't need that part. It's just a yes. All right, number 9. Evaluate the function at f of 6, f of -6, f of -x. So here's the function. Okay, we've done this one. Many of these we've done. It's so little available of different problems, and apparently I have no imagination. So f of 6, we're going to put a 6 in for the x's. So we get 3 times 6 squared minus 1 over 6 squared. Exponents come first. You know that order of operations has exponents first. So we get a 36 out of that. 3 times 36 is 108. So we get 107 over 36. F of -6, 3 times -6 squared over -6 squared. If you're using your calculator, be absolutely certain you put a negative and a 6, 2 parts, negative and a 6, in parentheses before you raise them to an exponent, or it's going to give you the wrong answer, because your calculator, if you write it like that, will think you mean what you've written, that only the 6 is getting squared. It won't recognize that you mean the negative also because it's not in your head. It does what you ask it to do. So this, if you miswrite it, will give you a -36. The negative's just sitting there, sitting in the man chair. You know those stores that have, when women go in and try on clothes, they got chairs for men to sit outside? That's what's happening here. The exponent applies only to his next door neighbor. So the minus just sits there while 6 gets squared. Here, though, what you're saying is the negative is getting squared and the 6 is getting squared because the exponent, remember, it only applies to its next door neighbor, and the next door neighbor is parentheses. So everything is getting collected in that square, and we get a positive 36. Same thing there, so we get 108 minus 1. We end up at the same answer, 107 over 36. Okay, when you take your test, you only have one of these. You don't have 3 separate answers, and I believe it's a -x that I gave you because we use it in so many different places. So 3 times -x squared minus 1. Okay, on the denominator, negative squared is a positive, x squared is x squared. Same thing's happening here. So -x squared gives you x squared. And as you know from somewhere else that we were working on in 2-point-something, we ended up with exactly what we started with. And so that tells us that this is an even function, that it has y-axis symmetry. But that's not what this problem is about. It's just a plug-in. Number 10 asks you to use your graph to find the value of f of 3. I'm asking you to use, must have been this graph right here. Yeah. Let me check the answer. Yep, that's what I'm asking you for. So what you want to do here, yeah, I'll write all over this, okay. F of 3, use this graph right here. You're going to go out, they've given you the x. You're going to go out to where the x is 3. So on the x-axis, go to 3. And then which way you're going to have to go to find your function? You're going to have to go down. So we go down to here, there. That's the treasure. We found the treasure. They've given us the x. They want you to give them the y. So it equals -2. They've given us the x. They want us to give them the y. That point right there is 3, -2. So they've given us the x. We give them the y. Number 11, use this graph to determine domain, range, x-intercepts, if any, y-intercept, if any, and f of 4. So playing some more with this stuff. Domain here, this should have an arrow here. Domain goes, that's the x-axis. What are we using up of the x-axis? Goes all the way to the left to -infinity, goes all the way to the right. Even though it goes down here, it'll still extend out on the x-axis. So the domain is -infinity to +infinity. The range, I get it that that's a little more difficult for your brain. It's a little more difficult for my brain also. The range is the y-axis, the thermometer. So we're thinking, shoot, we're thinking very cold down here. Still not on the axis, but today we're thinking cold. Oh, later this week it's going to be even below 0 temperatures. Let's see what this graph is doing. I see this graph sitting here. So here it's using up 3. There it's using up 2. Comes down here and it uses up 1, it uses up 0. This will extend and use up the cold temperatures on our thermometer. But we never get up here into the hot temperatures. So the range, what are you using up on the y-axis? If you want to think of it as squishing these pieces into the y-axis, smush that one into 3, smush that one into 0. It'll extend, smush it into -2, make it go into the y-axis. We start at -infinity way down here. Remember, you have to start on the bottom. And then it goes right up to 3. And it includes 3. So use a bracket at 3. The x-intercepts, where does this cross the x-axis? Well, this is not the best graph for that. Let's just say it crossed at 7. So the only x-intercept is at 7. And I know some of you are used to calling it 7, 0. This does not call, ooh, dang, now I'm thinking it does. You need to be able to name that point. And that's a skill you ought to have anyway. I'm not going to be backing up from any question that asks you for that. But if they're asking you for the x-intercept here, you need to be prepared to match it to 7, 0. Like if they have 0, 7 or 7, 0 for the x-intercept, you need to know that that point is not 0, 7. So if they give you the full point, instead of just the 7, be able to say, nope, it's not that one, it's that one. Y-intercept, where does it cross the y-axis? Crosses the y-axis right there. Let's call that 2.5. So that will be at 0, 2.5. You need to know that, not just at 2.5. I know that we call y-intercepts 2.5, but when you're given a multiple choice test and it has the full point, be ready for your brain to say, okay, I can recognize they're giving me the full point, and I can see that it is 0. Don't go sideways. Go up 2.5. F of 4, similar to number 10. They're giving you the x coordinate. Let's go out on the x-axis to 4, and then let's go up to our graph right there. They're asking you for the y, and the y is 1. They have given you the x. You give them the y. Oh, right. Let's see. Next problem, they're asking us for odd, even, or neither. That symmetry is involved in exponents. Technically, you're supposed to put a -x in here and see if it gives it back to you, but nobody's going to be doing that when you know a shortcut. So let's look at if the exponents are odd, all odd. Let's look at if these exponents are all even, or let's look if we've got a collection of both. So that's an even number. That's an even number. 2 is an even number. 4 is an even number. We're good so far. We're looking at even. This guy doesn't have an exponent, so we have to create one for him. Any constant that doesn't have one is x to the 0, and 0 is an even number. So this is an even function. You need to know that even functions match to y-axis symmetry. I may have. I did. Thank you. I will pick that up in just a second. Thank you. That kind of stuff happens. Appreciate it. So number 13, that's an even function because we've got all even exponents. If it's missing an exponent, it's always at x to the 0. So this is an even function that equates to y-axis symmetry. If it had been all odd exponents, that would correspond to origin symmetry. The O's, they both start with O's. And anything else, if we'd had a collection like an x to the 4th, an x squared, and an x to the 1st, that would be neither. Okay, thank you very much. Let's back up to number 12. The graph is here. We are looking for what intervals is it increasing? Where is it decreasing? Where is it remaining constant? Well, I can tell right now there's nowhere it's remaining constant. We're not floating along on a flat ridge, so there's nothing remaining constant there. Where is it increasing? Let me put arrows on these. It's increasing in this space. We'll catch that in a second. And it's increasing in this space. Where's your roller coaster going up? As you travel left to right is the question. So here's a space where it's going from, this will be an increasing, negative infinity up to that place right there. And that is negative 1, 2, 3, 4. That's negative 4. Now, this is the place where you never use a bracket because once you get to negative 4, you're starting on your way down. So that's always going to have a parenthesis there when you're coming up with increasing and decreasing and constant intervals. So this is a piece that is increasing from negative infinity as you travel left to right till you hit negative 4. It's asking you, where is it happening on the x-axis? The other place that it is increasing as you go left to right, it starts here, right there. That is 1, 2, 3 on the x-axis. So it is increasing also from 3 up to infinity. So those are both the places where it's increasing. Where is it decreasing? Where's your roller coaster going down as you travel west to east? Right there in that piece. From negative 4 to positive 3. So it is decreasing from negative 4 to positive 3. And you're always measuring it off of the x-axis. We will be using y-axis later for something else. Don't worry about it now. It's always about the x-axis when they're asking you about increasing and decreasing. Okay, get attendance there, and I'll take it again in a bit. Okay, let's see. In MATLAB, there was U symbols in the question. Oh, you're right. You're right. Yes. So when it's increasing in more than one place, they union them. So it would be, let me cut that off because that was decreasing. It's increasing from negative infinity to negative 4, union that thing. Big deal. It just brings them together. That's a bucket where it says this guy goes in there and this guy goes in there. They're both answers. So yeah, you'll see that union symbol there on my MATLAB. And let me see if I put that here, number 12. No, I did not I put it with a comma on your answer sheet. So you'll see it different ways. You're welcome, Ashish. Okay, I think I'm caught up with your questions. Let's look at graphing a piecewise function. Let's see, I'm going to go grab a graph and we're going to build a wall and we're going to see what's happening here. Okay, rearrange here a little bit. It's not going to happen. Okay, our wall needs to be at negative 2. So let me build a wall right here. There's our wall at negative 2. Here's my graph. And there I built my wall at -2. Something's going to happen to the left of it, something's going to happen to the right of it, but I cannot cross that line. Okay. Let's look at first what's happening in this first piece, where the numbers are less than -2. So the numbers that are less than -2, I know -2 is not less than -2, but I want to see what happens with this first piece right up against the wall. So I'm going to leave this open. I'm going to remind myself that's got to be an open circle there. And then I'll try the other numbers that are less than -2 that are near there. So -2 plus 3 gives me a 1. -1 plus 3 gives me a 2. And 0 plus 3 gives me a 3. Let's plot those here. Use a green one on this side. So -2, 1, that point is on there, but remember this says for x's that are less than -2, this -2 is not less than -2, so we've got to use an open circle there. Then we've got -1, 2, and we've got 0, 3. Oops, let me try again on that. Oh, nobody even noticed. Okay, these numbers are not less than -2, they're more than -2. So let me start over. Cross that out if you've got that on your paper. Maybe you noticed, but you didn't say anything because you thought you were stupider than me. You're not. You're not. So let's start over. We are looking at numbers that are less than -2. So -2 sure counts. Let's do that one. -2 plus 3 gives us a 1, and that will be an open circle right there. But then we're looking for numbers that are less than, and that's going to be a -3 and a -4, not -1 and 0. I just muffed it. So -3 and -4. Put them in there. -3 plus 3 is a 0. -4 plus 3 is a -1. Now let me try. Now we'll be on this left-hand side of the wall. There's -2, positive 1, open circle. -3, -1, 2, 3, 0 is right there. And -4, -1. And there we go. That's what that guy's going to look like on the left-hand side of the wall. Let's go see what the right-hand side of the wall is going to look like. This rule, this piece, where the numbers are greater than or equal to -2. So -2 is going to count here on the wall. -2 will count. And then we also want numbers that are greater than -2. So -1 and 0 here. Okay, let's plop them in here. -2 minus 3 is a -5. -1 minus 3. And 0 minus 3. Let's go graph those little guys. So I've got -2, -5. -2, -5 is right here, and that'll be a filled in circle. That counts because -2 gets to play in this row, in this piece. Then -1, -4, right there. And then 0, -3, right there. Okay, nobody gets to cross this line, so don't think this guy gets to come down here. Because if we tried -3, he doesn't get to play there. He has to go play up here, where the numbers are less than -2. So we end up with this graph. That's an arrow there. That's an arrow there. Okay, let's look at number 15. Find the slope. What's the line doing after you find the slope? So slope equals, it's always a fraction. It's always a subtraction problem. On top, we're going to subtract the y's. And so I just generally look for the easier one. 8 minus 3 is easier to me, but I know some of you just have that formula, y sub 2 minus y sub 1, that you can use or not use. It's not a big deal. I know that a lot of you like to go this direction, so let's go this direction. So 3 minus 8 will be on top, and we'll get a -5 out of that. And then if you've gone from the right one to the left one, you have to be consistent when you go to the denominator and do the x's. So that'll be a 1 minus -3. got a double negative there, so we end up with 4, and that's our slope. Find the slope, did. Is the line rising, falling, being horizontal, or being vertical? It's got a negative on it, so it is definitely falling from left to right. For instance, let's look at it. -3, +8. Let me put this on here with a purpley. I'm just going to put it on this graph so you can see. -3, 1, 2, 3, +8 is up there. 1, 3 is right there. Connect the dots, and you can see that that is a negative line. It will fall from left to right. And we've got a negative on it. We should have a negative on it. Okay, next problem, number 16. See how we doing on time? Good. We've got a good solid 20, 30 minutes left, and we got 10 problems. We're doing great. Let's see. I'm seeing Gage in there. Gage, you're not going to have a private conversation right now, so the rest of y'all talk amongst yourselves. Gage, you were, well, actually, this does involve everybody. Gage wrote me yesterday concerned that he thought he had done some of my math lab problems, but when he went back to look at my math lab, he couldn't find them. And I was thinking this morning, Gage, that maybe if you could prove to yourself if you had done them or not by finding your scratch work where you had done them. Did you ever resolve that in your mind that you had not done them, or does anybody else in class, have you ever had the experience where you've done my math lab work and you come back and it's missing? Yes, Felicia, if you get a dry board, you can use that, yeah. So Gage, Gage was not doing the practice problems. He was doing 2.1, 2, 3, and 4, and it felt like he had already done them. And when he went out to look, he hadn't done them. He felt like he'd just done them the night before. So I was hoping to hear from Gage to see if he was going to tell me that either he found scratch work on it, so he must have done them, or he's just decided he got confused or something. But Gage is either writing a lot or he's in the shower. It's hard to tell. Okay, let's go to number 16. Yeah, I know you did them afterwards, but I mean the night before you thought you had done them. Did you ever reconcile that? Did you ever figure out? You can open your mic if it'd be easier. Did you ever figure out how you, I don't know, ever reconcile that? Okay. Yeah, sadly, no kidding. But if you had scratch work from it, and you would have had to have had scratch work, yeah, you don't need to click that, Amanda. I have never, in 20 years of working with my math lab, I have never heard from any student or any teacher about a student that has happened to. So you can click save if it just makes you feel, you're a person who locks your front door every day, that kind of thing. But you don't have to. It'll save. I've never heard of anybody having that experience. So I just thought, Gage, that you could double check. If you don't have scribble sheets on the work, then you didn't do it. You just got just meant to do it or thought you'd done it or whatever. Okay, let's get back. Number 16, write the point slope form of the line with the conditions described. Then write it in slope intercept. So we're going to do the full thing on it. Here's what we've got. Slope equals 4, and it's passing through -5, 2. Okay, we've got a point, and we've got the slope. So let's use point slope formula. That's our helper equation. Y minus 2 is the y coordinate. The slope is 4. X minus -5. That's a double negative there, so make it plus a plus. So now, there it is, right here. This is point slope form. We're done with the first question. Then they ask you for slope intercept. That's a simple two-step distribute and then move the 2 across. Let's first distribute. And then plus 2 on both sides. Don't know why that's orange. I don't usually put that in the other color, but it's okay. Y equals 4x plus 22. They're the two answers they were looking for. Point slope, put the point in, put the slope in, do the work. Knead it up a little bit. Then to get to slope intercept, do distributive and then move the two over. So there's slope intercept. And sure enough, it's got the slope sitting there. They told us the slope was 4. There you go. And the y-intercept, meaning if you were going to go graph it, you go way up there to 22 to begin, but you're not graphing that one. Okay. Number 17 is a very easy problem. Some of these are very quick and very easy. Very few of them will take you much time, I hope. Number 17. Give the slope and y-intercept, then graph. So we've got this as our problem, and you're asked to give the slope. So the slope is just always sitting there in front of the x in y equals mx plus b form. So it's -3. Or if you want to make it a fraction, -3 over 1. I'm pretty sure you're going to have this to pick from, but you should be able to recognize that as being the slope. And the y-intercept is sitting back there, 2. If you have a problem like this and they give you y-intercept as being 0, 2, I may think about giving some points back on that because a couple of you are used to this as the y-intercept, but not all of you are, and in all of your My Math Lab, you were just given that back number. So anyway, let's go graph this. Let me grab my little board. It disappeared. Oh, there it is. Got buried. Okay, we're going to begin here. Remember, that's what B stands for, not really. So let's begin at 2. You go up to 2. There's where I'm going to begin. This is the x-axis right here. I'm going to begin on the y-axis. Always you begin on the y-axis at the y-intercept. That's that number back there, always. And then I'm going to move. That's what the M stands for. Rise over run, down 3 and over 1. So from here, go down 3 and over 1. You're always going from the beginning point, from the y-intercept. You don't go to the origin for that. When you're graphing a line, you start at the B, at the y-intercept, and then you move from there. Down 1, 2, 3, and over 1. Look at that line and ask yourself, is that a negative slope? Yes, I would be falling from left to right. That airplane is taking off in the negative direction. So it should have a negative slope. It does have a negative slope right there. So at least I know my line's going in the right direction. Okay, let's look at number 18. Write in both point slope and slope intercept this information. It's passing through -3, -4, and it's going to be parallel to y equals -6x plus 1. Okay, in order to put it in point slope, you need a point. We've got a point, and you need a slope. We don't have a slope, but we've got enough information and enough knowledge about slope and parallel to know that when you've got parallel lines, the slopes are identical. So there's our slope that we're going to use. So we do have a point right there, and we do have a slope right there. So let's use that marvelous helper equation and plug in the point into the appropriate places and the slope into the appropriate place. So y minus -4 equals the slope is -6, and then x minus the x coordinate. Let me clean it up a little bit. Double negatives will cancel. So y plus 4 equals -6, x plus 3. That's point slope because you can see a point. -3, -4 is the point, and you can see the slope. Now they ask us to do slope intercept, so 2 easy steps. Distribute and move that 4 over. -6x minus 18, and then -4 on both sides. And there is slope intercept form. Okay, Number 19, similar kind of problem. We want both point slope and slope intercept. It's passing through 3, -4, and it is perpendicular to the line whose equation is y equals 1/6 x plus 1. Okay, if we're going to do point slope, you know what we need. We need a point. We've got it. And we need the slope of the line. Well, we've got the slope of the perpendicular line. We don't have the slope of the line. But you know that if one line has a 1/6 as its slope, its perpendicular will be the negative reciprocal. So our slope that we need, the slope of a perpendicular line, the one we're looking for, will be, this is positive, so ours will be negative, and it will be the reciprocal of that. So it'll be a -6. So now we've got a point and we've got the slope. Let's use our wonderful little formula. Y minus -4 equals, slope is -6, and x minus 3. Let's clean this up a little bit. We got a double negative there. So y plus 4 equals -6, x minus 3. Okay, that's point slope because you can read the point off of it, 3, -4, right there. And you know the slope is -6 because you have knowledge about perpendicular lines. Now let's clean it up and do slope intercept. Distribute and move the 4 over. -6x plus 18 minus 4. There we go. That's an equal sign right there. Okay, let's look at number 20. Right in slope-intercept form. Slope-intercept form. It passes through 4, 6 and is perpendicular to the line whose equation is y equals -3. This is one of those super duper easy ones if you know what to do. I mean, so much of life is easy if you know what to do. Y equals -3. Find on the y-axis -3. It's, you know, right there somewhere. That's -3. And then draw a line perpendicular to that. So there's the line y equals -3. A perpendicular to that is going to be an x equals. So our answer is going to be x equals, and then just look and see what the x coordinate is in the point that belongs to this line. It's a 4. So there's our answer, x equals 4. Let me find that point, 4, 6. Over 4, up 6, somewhere here. If we want this perpendicular line right there, because this one's y equals, you know that one's x equals, and then you know that every one of these points goes out 4, out 4, out 4. So it's equal to x equals 4 because we know it right there. The x coordinate is a 4. It's one of those super easy ones. I went over about 4 of those yesterday, or yesterday. Okay, that's number 20. Let me grab the rest of them. I added to that list because I wanted to, anyway, blah, blah, blah. Number 21, we're doing difference of 2 squares here. You're factoring. These are 5 extra problems that I added in because I wanted you to have 25 problems. I don't want each one to count 5 points. 4 points just adds up less quickly. So difference of 2 squares, the problem that I gave you is 36x squared minus 121. That's a perfect square, that's a perfect square. So we're going to factor that into 2 sets of parentheses. What's the square root of 36x squared? That's 6x. We have a minus sign back here, so I know the signs need to be different. And then what's the square root of 121? So end up with 6x plus 11, 6x minus 11. Right? Let's look at our last 4 little problems. Remember, yours will not be in this order. Your problems will be randomized, so your order will be different from anybody else's. Number 22. Let's look at number 22. Solve this trinomial, 6x squared plus 19x plus 15. Okay, let's see. Is there a GCF for all three terms? Is there something we can factor out? No, 19's a prime number, it's a dud. So with 6 is a composite number. Don't go after 1 times 6. I know it worked earlier, but generally speaking, when you're factoring, the book, the world, goes after the numbers that are closer together. So 1 and 6 are out here, 2 and 3 are somewhere in between that make 6. Use those. So 2x and 3x, the signs need to be the same and they'll need to be positive. And then I'm looking for two numbers that multiply to give me 15. Those two numbers are not going to add to be 19 because I got a big old fat number here. If I put something back here, that number doesn't stay the same. He's going to multiply times 2. Anything in here is going to multiply times 3. So when you've got a number in front of your x squared term, you don't play the what multiplies and adds to give you 19, but you do play what multiplies to give you 15. So I'm going to go after, instead of 1 and 15, those are too far apart, I'm going to go after 3 and 5. Those are closer together. Now don't put 3 here. I know we looked at one of these earlier, but I'm going to save you some time. Don't put 3 there, because if you put 3 there, you have created an embedded GCF. Those both have a 3 in common. If this were to be correct, that means we could have factored out a 3 up here, and you can't. So there's no way that 3 is correct there anyway. So let me just put him over here. And then a 5 there. Now, you knew 2 times 3 gave you 6. You got that? You don't have any worries about 6x squared. You know 3 times 5 gives you 15 because we picked only numbers that multiplied to give us 15. What we don't know about is this guy right there, 19x. Let's see that we got that. Let's see that we achieved that. Outside is a 10x. Inside is a 9x. Good deal. We've got 19x and we're good to go. So that's the answer. This test is a multiple choice test. If this is one of your choices and you're not good at factoring, play it smart. Foil that back out. If you can foil this out to get to there, it's the correct answer. If you foil this out and you don't get to there, it's not the correct answer. So be a smart test taker. If they give you all the answers, see if it works. Number 23. Got x minus 4. Nope, that's not right. That was my original. X minus 5 to the 4/3 equals 625. Okay, we're having to solve this for x. Everybody's raised to the 4/3. So I am going to take everybody in here and raise them to the 3/4. Raise them to the reciprocal. It's our third one like this to do. We're left with x minus 5 there. Whatever you do on one side, you've got to do on both sides. So we're going to raise that to the 3/4 power. So we've got 625 raised to the 3/4 power right here. You may use your calculator to find the answer. You may go 625 humpy 3 ABC 4. 625 humpy raised to the, and then 3/4 power 3 ABC 4 equals 125. So I know this is going to be 125. But this is one of the problems I'm going to check on, and if you don't show me the steps, I'm not going to give you credit for it. So what I'm looking for on this one is put 625 in the radical, the denominator is the index, and then raise that up to the 3rd power. So I want to see somewhere that you've got this written, and then I want to see what the 4th root of 625 is. Let me show you how to find that on your calculator. 4th root, let your calculator know you want the 4th root. Then let's go use this key above the humpy. So 2nd humpy, the 4 is the x, that's the index of 625 equals, it gives you a 5. So this mess is 5, and then you're doing 5 to the 3rd power and getting 125. So I want to see that you recognize the rational exponent equals this radical, and then I want to find a 5 somewhere. You can write it as a separate step. You can, whatever, but I want to see the setup, and I want to see, and you can check it. I'm happy with you using your calculator, but I also want to know that not only is it in your fingers, it's in your brain. We're going to use this concept later, and I want it now down for you. Okay, this is not the answer. X minus 5 equals 125. You got to add 5 to both sides. So X equals 130 is the answer. And you can check it if you feel like it. Put it back in here, 130 minus 5, that's 125. And you can raise 125, humpy, 4, ABC3, and that gives you 625. Any problem that has an equal sign, and so many of the problems on this test have equal signs. Every problem that has an equal sign, you can plug your answer back in and see if it works. If it works, it's the right answer. And somebody maybe in this class, I was thinking, I don't see who I thought it was earlier, asked me, if you guess right on this problem, but you don't have this work showing. So let's say you guessed it was 130 because you plugged them back in, but I don't see this anywhere. Am I going to count it wrong? Yeah, I am. I'm going to go pick 4 or 5 problems and spot check your scratch and make sure that you've got scratch for them. And this would be one of those problems. So if you plugged them back in and just guessed and got the right answer, but I don't see this, I'll change your grade on that. Sorry, that's what I'm going to do. Not on all of them, just on 4 or 5 that I feel like you need to know the process. Okay, number 24. Here's the problem. F of x equals x squared minus x minus 5. And g of x equals negative 2x plus 8. You're asked to find g of 3, and it's a totally separate problem. Find f of g of 3. So we're first going to plug a 3 in the g equation and get an answer. Then we're going to take that answer that we have and plug it into the f function. So it's 2 steps here. Let's do g of 3 first. So g of x is negative 2x plus 8. I want to know g of 3. So negative 2 times 3 plus 8, negative 6 plus 8, I'm getting a 2. So g of 3 is 2. There's my answer. Let me box that sucker up. That's the first answer, but it's crucial because we're going to use it right over here. If we're going to do f of g of 3, let's figure out what g of 3 is. Well, we know g of 3 is equal to 2. So in place of g of 3, we're going to put a 2. So our game is really just to find f of 2 because we've already found this. That's what we're going to do with the first part of the problem, is to find the interior piece. So if we're looking for f of 2, let me grab f of x equals that. So I'm looking for f of 2. I'm going to put a 2 in there and a 2 in there. 4 minus 2 is 2. 2 minus 5 is negative 3. And that's the final answer. Both answers are good. 2 because they asked you to find g of 3, and then negative 3 because they asked you to find f of g of 3. So this will be the interior part of the second half of the problem. And then the last problem on here, I'm asking you to graph x equals negative 3, and then graph y equals 4. Let me grab my graph board for that. So we're going to graph x equals negative 3. There's the graph. Here's the x-axis. X-axis, we're graphing x is negative 3. X equals negative 3. So let me go find on the x-axis where negative 3 is. Negative 1, negative 2, negative 3, right there. And then my line is going to go through all the places where x is negative 3. So that's going to be right there, because that point right there is negative 3, 1. It's going to be that point, negative 3, 2, etc. It's going to be all of those points. and that line happens to be perpendicular to the x-axis. This is parallel to the y. It kind of feels backwards until you look at it a little bit. Okay, that's x equals -3. Just to talk about it, if we wanted to know something about that line, I could ask you what color his eyebrows are, or how tall is he, or I could ask you for his slope. And you would say, well, his slope is undefined. I cannot climb that. His slope is undefined. That's a vertical line. But his name is not undefined. That's just something we know about him. Okay, the other line I wanted you to graph, to know how to graph, is y equals 4. So let's look at y equals 4. Find on the y-axis where y is 4. Here's the y-axis, 1, 2, 3, 4, right there. That's y equals 4. Is Felicia still around? Yes, ma'am, she is. Felicia, you had asked if you get one of these graphs, can you use it? Absolutely, but do not use a permanent marker on it. Be sure to get expo markers, dry erase markers. I can tell you how to fix that problem if you screw it up. It's really easy fix. But, and then show me that it's clean on both sides when you do your scan, just like a scratch piece of paper. So those of you who are using graph paper, you're welcome to use graph paper. Just show me the graph paper just like your scratch, or this if you're using this. Okay, so y equals 4. There's where the y-axis where 4 is. Every point that is equal to where y is 4, there's 1, 4. There's 2, 4. All those points. So there's the line y equals 4. It's a horizontal line. If I was interested in some other detail about him, you could tell me what size shoes he likes to wear. And you might tell me that his slope, you might know about his slope, that his slope is 0. There's no effort in crawling across that line. That's just walking across the floor. 0 is his slope. His name is not 0. His name is y equals 4. Okay, we are done with those 25 questions. What questions do you have? Anything? Yes, Amanda.
On 21, when you do it on My Math Lab, is the way you gave it to us on your example was only like 2x plus 3, or wait, no, wrong one. The 6x plus 11 and then minus 11. But on the My Math Lab, it says it wants you to put in like 16x squared plus 9 and then those two. It's like 3 of them.
For this problem, it wants you to do something else?
Yeah.
Oh, I'll bet you got something like, let's see, you must have gotten something like 81x squared minus 121, let's say. No, that won't even do. Minus, shoot, 64. Then you broke it down into 9x squared minus or plus, that's,
well, on My Math Lab, it has it to the 4th power. Never mind. I guess that's what the difference is.
yeah, that's more difficult. That's more difficult. And then you could factor this, well, the difference of 2 squares. It has a double difference of 2 squares. That's more difficult than the one that will be on the test. So yeah, yours ended up like, you end up with 9x squared plus 4 and 9x squared minus 4. And this is still a difference of 2 squares that you can break that down into 3x plus 2 and 3x minus 2. That's more involved. Certainly we looked at a problem like that, but this will be how your test, there. This will be how your test will be. It'll just break up once.
Okay.
I even rejected a double one thinking that was just more than I wanted to cover with you. So yeah, yours will just break up into 2 sets of parentheses and you'll be stuck there. Like you said, they left you with a square that could still be factored further on your My Math Lab program, but I won't on the test and I didn't on the review.
Okay.
Anybody else? Okay, you've got, the test won't open till noon. Don't go take the test until your homework is done. Don't, get your homework done first. It's dumb to take a test and then back up and do the homework. Where do you access the test in My Math Lab? No, Luce, it's the same as before. You go to Proctorio, test Proctor or something, and then go, your exams are here. Yeah, so I know that you may have had a semester where you went to my math lab. This is not that. I've gotten better at that. You go through Proctorio, same as where you went for your practice test. Yeah. I did for 2 tests, Luce, and then I said, screw this. We're not going through my math lab anymore. That was way too difficult. Oh, any of you that went to my math lab for your tests, you know what I'm talking about, and the rest of you don't need to know. So go to just regular Proctorio where you'll go in just like before. It'll feel so much like your practice test, I hope, because that's the goal, is that you've had a practice attempt. So it is on Blackboard at Proctorio Test Proctor. Your exams are here, where it says your exams is, where's my other hand? There it is. Your exams are here. And then open it up and you'll see your exam there. And the instructions, you know, same thing. I'm trying to make it as much like the practice. I'm trying to make nothing new for you because I want you to do well. That's my goal, is to teach you in a way that you can learn. So get all your homework done. Do that first. Go out to my math lab and get all that homework done. Get 8 1-point bonus points for yourself. Then go take the test and do well. Don't cheat. Proctorio will catch you. And do well. Start off on a good basis here. You guys are doing such a good job of attendance. You're doing such a good job of keeping up with your work. I feel really good about you getting out of this class in a pandemic. So yay for you. Email me if you have any questions. Be sure I get your test scratch paper within 5 minutes. And I'll stick around until everybody else is gone. So if you have questions and you want to stick around, feel free. What happens if you run out of time and the only, just a second, Jennifer. Let's see. Guess the answers and get some of them right. I'll be interested to see how long it takes you. Try not to take a long time, but don't get panicky. Keep a pace, 25 minutes, and I'm going to change it to 120 minutes. So let's see. That's 120 minutes divided by 25 problems. That gives you almost 5 minutes apiece. That is that's in the glare, sorry. That is a lot of time, 5 minutes, because some of them are just not going to take you 5 minutes. So I think you'll be surprised. I'm even going to write myself a note to check on your time. I think you'll find, and yeah, guessing is better than not guessing. And if it happens to be one of those problems where I'm checking, you'll miss it. But yeah, I would go and guess as best you can. But Jennifer, I really don't think you're going to have trouble with the time. We'll see. But yes, go guess. Go spend your time. If you've got 2 minutes left and 4 problems left, go guess. Do a best guess. Another thing you might think about doing is, if you see a problem that you know is going to take you a long time to do, skip it. Just skip it and come back to it. Make yourself a big old fatty note, though, at the top of your sheet. Jennifer, go back and check number 7 and number 11, that kind of thing. Keep track of what you need to go back and look at so you don't end up forgetting them. But that might be a strategy, is to save the slow ones, because everyone counts only 4 points. I'm going to stop recording this. And if you want to stick around, if you want to go